Ted. And yeah, what you heard from Zach was a good lead-in. He talked about the 20% flow reduction strategy and distributed storage. And so I'll talk about a specific project that fits into that scheme. And it's a Redpath project. It's a project that's been in development for well over a decade. Like so many of these impoundment projects, they take such a long time, and they can be quite a big lift. And so we're happy that we're finally at the finish line with the Redpath project. And so I apologize if you heard some of you I know have heard this presentation before, but at this point we're going to take every opportunity we can to talk about Redpath until we get it built. So if you're sick of hearing from me, maybe write a check and we can take care of the problem. But so with that, oh, and by the way, this is a Bois de Sioux project, Bois de Sioux watershed district down at the headwaters of the Red River Basin. And Linda Vavra is here today as well. She's the president of the Bois de Sioux. So with that, the Redpath Impoundment Project, again located within the Bois de Sioux watershed on the Minnesota side, is just northeast of Wheaton, Minnesota. And the project is located within the Mastinka River watershed. The Mastinka River is a river that discharges to Lake Traverse. And Lake Traverse is held back by the White Rock Dam. And the White Rock Dam is the first and the largest impoundment in the Red River Basin. And that project is operated by the Army Corps of Engineers. So the purpose of the Redpath project is to facilitate another project that you heard about in the previous presentation, the North Ottawa facility, also shown on the slide there. The North Ottawa project controls about 74 square miles of watershed, and the Redpath project will control about 200 square miles of watershed. And the purpose of the Redpath project is twofold, like many impoundment projects. First and foremost, it's to serve as for local and regional flood risk reduction. And then secondly, this project has a component of a natural resource and water quality element with the rehabilitation of the Mastinka River. And as you know, the days of building main stem dams is kind of come and gone. In the upper reaches of watersheds, it's still possible in some areas, but at these locations towards the bottom ends of these tributaries, and when we're talking about wanting to store water from the river channels themselves, we have to be creative in how we get the water, from that river channel into an impoundment facility without creating a main stem obstruction that has negative impacts for fish passage and natural resources. And so this project is kind of unique in that aspect, is it's a great example of how to store water in an off-channel way on a major tributary main stem, or next to, I should say. So with that, a little bit about the background. As you heard, as you know, we've heard this for a number of years. We are in a wetter climate now. It's no different with the Mastinka River watershed. There is a USGS gauge near the outlet. And since the 1980s, we've had, I think 11 times we've had an annual peak flow recorded over 4,000 cubic feet per second. There was a period of record where data was not collected, but prior to the 1960s, it only occurred once since gauging began in the early 1900s. So confirming what we're seeing basin-wide there. Here's just an image taken of the Mastinka River watershed along the main stem in 2019. That was the last significant flood that we had. So looks very reminiscent of Red River Basin flooding in the glacial lake plain. And of course, the flood damages are heavily concentrated in the flat glacial lake plain area. This map that you see on the right, each red dot represents a FEMA damage site in the 1997 flood. And as you can see, they're primarily located in the downstream areas of the watershed as opposed to the upstream areas further east. And so these projects, when they're sited, near the beach ridge where the change in topography occurs, are really ideally situated to help reduce future flood damages in these areas. Okay, so just a little bit about the Mastinka River, because it really is representative of a lot of other tributaries in that when flows reach the flat glacial lake plain area, they begin to break out. And when they break out, the flows tend to cross watershed boundaries and enter into other river systems. And this is, again, a phenomenon that occurs up and down the basin. But in this particular area, water will break out and go north prematurely, so the flows won't go into the Lake Traverse Flood Control Facility, and therefore the ability to control is lost. And so it's short-circuited or circumvented, if you will. And those flood flows go into the next watershed to the north, which is the Rabbit River. And that one can become overwhelmed and jumped into the next one north of that, which is Doran Creek. So it begins to be a domino effect. And one of the key benefits of this project is that it will help mitigate, prevent those river breakouts and put that water into storage. Flooding in this area has been something that's been on the radar for a long time, and there's been attempts to address it in different ways. And early on, the solution was to simply channelize the river. So the Mastinka River in the early part of the last century was channelized and straightened and converted into what's now known as Judicial Ditch 14. And while that provided improved drainage for these smaller summertime events, it really did exacerbate flooding. And so at the end of the day, we have 43 miles of natural sinuous river and floodplain that was converted to just 25 miles of straightened channel. And so this is a section of the straightened channel that is, as you can see, it's trying to re-meander, and nature, it's doing its thing. It wants to turn itself back into the Mastinka River again with its oxbows and so forth. And so that's why a key element of this project is the rehabilitation of the Mastinka River in tandem with the flood impoundment. And of course, a lot of studies have been done. The One Watershed, One Plan is completed for the Boy to Sioux watershed, and then we had the RAPS reports prior to that, documenting the problems with the Mastinka River, the sediment load and the impairments and the issues that creates for fish and wildlife and so forth. And so we have a lot of justification for doing the project. So the project itself consists of basically 3 sections of land that are utilized for the storage of floodwaters immediately south of the Mastinka River, or JD 14. And then there's a bypass corridor around the north side where the rehabilitation of the river will take place. And then we've got an inlet channel as well. And when you add all of those features together, it amounts to about 4 sections of land that was acquired for constructing this project. And those land rights are acquired in different ways for different projects, but in this particular project, the land was acquired in fee. All 4 sections. The Boy to Sioux owns the property. They've been leasing it out for agricultural production. And so this facility will primarily be used for spring snowmelt runoff events. And so the ag land on the interior will continue to be farmed, but it is subject to flooding in the summer if we have excessive rainfall events that require the use of the property. So those lease agreements will have that stipulation that there's that risk. And again, along the north side is the bypass, and we're gonna talk about that in a little bit more detail. But so just to kind of talk about some of the statistics with the project will store 23,000 acre feet of floodwaters for the 100-year snowmelt. And the gated storage component of that is about 19,000, so it's about 2 inches of storage from the watershed. And basically, I was kind of use this line to describe it, but if you were to take 200 square miles upstream of the impoundment, of a water depth of 2 inches deep, so 200 square miles, 2 inches deep. That's what the facility stores at the gated elevation. And then of course the levees are quite extensive, being that it's an off-channel. Over 10 miles of levees with 24-foot wide tops, 4-to-1 slopes, and it's essentially a dry dam. The Mastinka River rehabilitation will be over 4 miles in length, over 5 miles in length. There is it's a 2-stage channel with a meandering low flow pilot channel. That low flow meandering channel will be about 8 miles in length, and there'll be over 2 million cubic yards of excavation to construct that rehabilitation corridor. And of course, that material will be used to build the levees for the impoundment. And there'll be recreation opportunities in that corridor as well when it's complete. So that's another added benefit of the project. The first component, I'd just like to briefly touch on a few of the items. First and foremost, the meandering channel design. And so it is a 2-stage channel along the northern perimeter outside of the levees. And what will happen is the normal everyday base flows up to the bank flow event, the 2-year event, will be conveyed along the exterior of the impoundment. And on the upstream end, the impoundment will be bypassed. And then when we get excessive flows, the excess water beyond the bank flow will be peeled off and diverted into the diversion channel. And you'll see a little bit more about that in a little bit here. But the rehabilitation project itself, you can see the 3D rendering here of the sinuosity of the low flow channel, and then we have the secondary bench kind of serving as the 2-stage. And so this was done with river geomorphology principles, so that we would have a stable design that would carry the sediment load. Also within the bypass corridor, there will be wetland mitigation that takes place. The project did have some wetland impacts where levees would be constructed. And so within the bypass corridor, on the outsides and insides of the meanders, will be depression areas that will be constructed wetlands to serve as mitigation. And I believe we're even talking about doing some additional wetlands, and depending on how much of a lift we want to take, maybe we'll look at a bank. But anyway, there'll be wetland mitigation within that corridor. So at the very upstream end of the project is kind of where the magic happens that I talked about earlier with the flow split. And so you can see the 2 structures. The structure on the right is the inlet to the rehabilitation of the rehabilitation project, and the inlet on the left is to the channel where excess flood flows would be conveyed to the storage facility, the Redpath impoundment. And so the wall on the right has orifices that allow those flows up to the bank full 2-year event to be conveyed around the impoundment. But then when flows become larger than that, it starts to become a restrictor. And when that occurs, the excess flows are pushed over a low head weir wall into the storage facility. And all of this was done with fish passage in mind. And so here's a close-up of the inlet to the bypass corridor with the orifices. This is much more beneficial for fish passage than culverts would be, because they just have a very short distance to go through the structure. And then the impoundment weir is shown here to scale with a human standing there. And this also includes an inflatable bladder across the top. And quite a bit, that was something we really tried to avoid, to be frank about it. But at the end of the day, it was needed in order to maintain the depth of flow that's required in the bypass to maintain the full bank 2-year flow. And then when the weir is overtopped, it automatically lowers. and then water is brought into the impoundment. And then what that does is that reduces the head and therefore the velocity across the inlet structure to the bypass, and allows fish passage to occur for a greater duration, for a greater period of time. And then finally, another key feature of the impoundment is the outlet structure, very typical of a lot of projects. A gated structure. This has 2 gates for redundancy and a large concrete box culvert. And when this is open, the conduit will provide conveyance for a 10-year, 24-hour event without inundating the agricultural fields on the inside of the impoundment. And the purpose for that is we decided to complete the design with 10-year protection for the ag lands inside if we so choose to leave the gates open in the summer. And so when the gates are closed, the impoundment fills. You can see in the graphic, it fills from the bottom up. And water goes into storage. And at the end of the day, if we have a significant flood event that can fill the facility, for the 25-year 10-day, we can reduce peak flows by 75%. And for the 100-year snowmelt, we can reduce peak flows by 24%. And in terms of volume, for the 25-year 10-day, we can put about half of the flood volume into storage, which is quite significant. And for the 100-year snowmelt, about 27% of the volume can be put into storage. And we have modeled this project. This project's about an hour-and-a-half drive from the city of Fargo. And with the main stem modeling that Zach talked about earlier, we can actually measure the reductions, the slight reductions off the peak at the city of Fargo. So, you know, hour-and-a-half drive is a long drive, and it's a project's a long ways away, but it's a large enough project in Timeswell that you can measure the benefits at Fargo. And so at the end of the day, these projects are multi-purpose, and that's the beauty of them. So we've got flood risk reduction, which you've seen, the natural resource enhancements, water quality improvement, and recreation, and all of that is built in, and the benefits and the benefit of the project. So this project, it's like I said earlier, it's ready to go. We've acquired our Minnesota Dam Safety and Public Waters permit in November of 2021, and we're putting the finishing touches right now on our 404 permit with the Army Corps of Engineers. We expect to have that in 6 weeks or so, and then we're ready to go to bid. And we're going to bid the first phase of construction, which is the relocation of a 103 ditch system or a legal ditch system next to the facility. We're going to bid that project this winter, and so that'll be the first phase of construction. There'll be 3 additional phases after that we're planning on. And so this is kind of the let me check here. Yeah, this is the final slide of my presentation, and this is basically our funding strategy for the project. And the columns across the top with the years, if you can see that in the blue, we have phase 1, phase 2, phase 3, and phase 4. And what phase 1 is the project that's going to bid this winter, the relocation of that drain. Phase 2 is the excavation of the bypass corridor, those 2 million cubic yards, and bringing that material and using that material for the construction of levees. Phase 3 is the construction of the remaining levees, the southern perimeter levees, the east and west. And then phase 4 is the construction of the structures, the concrete structures. And we have a number of funding partners. The funding partners on the top that you see in green are the ones that have an interest in natural resource enhancements and water quality. And you can see all of that occurs in phase 2 with the rehabilitation of the Mastinka River. And if the dollar amount is shown in green, it means we have secured a commitment. So basically the $7 million cost of phase 2 shown in green for the Mastinka River rehabilitation, we basically got that funding. Lessard Sam's Outdoor Heritage Fund, the Bowsers through their Clean Water Fund, the Red River Watershed Management Board, the Bois de Sioux Watershed District, and we've got a grant application in with LCCMR, and the legislature will be processing that this biennium, and But we're really encouraged by it because of all the projects in the state of Minnesota that submitted an application. This project ranks second, and so we're sitting good there. The bottom half of the table is shown in blue, and those are our partners who have an interest in flood damage reduction. And really, the key or the linchpin to this project, really getting going, is funding from the state of Minnesota. And so we're hopeful with this biennium and the good position that the state of Minnesota is in, and the Red Board is working on a bill that we can get this project to go and finally get it in operation for everyone's benefit. So all told, it's $40 million yet to go to get it on the ground. So that's the conclusion of my presentation, and I want to thank the Red River Basin Commission for allowing the Boy to Sue to present the project.